Now, I want to explain to you what similar triangles mean and how you can identify similar triangles. Okay, now I have three cases for you for when two triangles are similar, okay, or two figures, whatever it is. You can use it for triangles, any other figure, okay, when two figures are similar. All right, now the first example or the first case is side, side, side. What do I mean? Now, if you look at this triangle, it's X, Y, and Z sides, right? Now, you see here in the other triangle, let's call this one 1, let's call this one 2. In triangle 2, you have NX, which is a multiple of X, NY, which is a multiple of Y, and NZ, which is a multiple of Z. So, for example, let me say if X is 3, Y is 4, and Z is 5. Then you have another triangle that has maybe 6, 8, and 10. These two triangles are similar because the sides, this side, right? The side of triangle 2 is just a factor of the sides of triangle 1. All right, so that's what we mean side, side, side. Now, all three sides, not two sides. Okay, all three sides, very important. All right, now the second case is called angle, angle, two angles. So if you have triangle 1 and triangle 2, right? Now, of course, you see that triangle 2 is bigger than triangle 1, right? But you notice something, they have the same angles, corresponding angles, X, Y, X, Y. You see that? So these two triangles are similar because two of their angles are the same, are similar. Okay? X, Y, X, Y. All right? Of course, note the places where they are congruent. That's what we mean by congruent. So X here, Y here, Y here. All right? You just need two of that, and they are equal, and they are similar. Okay? Now, then we see the third example or the third case of similar triangles is when you have side, angle, side. What does that mean? Two sides and an angle. So two sides and the angle between them. Okay, so you see here Y, Z, and X. Angle between them, right? Then you see NY, same side, but now this is a factor of this. NZ, which is a factor of this guy. Then X, the same angle, X. So these two triangles are also similar. Okay, so make sure you know the three cases where you have similar triangles: side, 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 angle, angle, and side, angle, side. So before when you see a geometric question and you are asked and you are told that you want to know whether they are similar or not, check if any of these cases are fulfilled. If any of these cases happen in that figure, then the two triangles are similar, or the two figures are similar. So what happens if the two figures are similar? What happens is that you can now create a ratio or a proportion. You've learned that in the module. If you've not watched that, you can go ahead and watch ratio and proportion. What does that mean? Okay, so if you have, let's say this, let's use this one for example. Now we've identified that these two triangles are similar, right? So let's call this A. Maybe we should call this V, U, W. Then let's call this A, B, and C. Okay? Now, because you've identified that these two triangles are similar, right? What you can do is you can create a proportion, like I said. So you say V divided by what is the corresponding side to V here? A, right? Equals U divided by B, okay? Which is equal to W divided by C. This is the proportion you can create for for similar triangles. So that means if I know this guy, if I know this guy, and I know this guy, I can get this guy. I can just use a proportion here. So I will just say V over A equals to U over B. So I know V, I know A, I know U, I can know B. So I will just slot this in and make you and find you. You see, so whatever side that is unknown, you can find using this proportion. All right. So, but the first thing you need, the major thing you need to know, the main thing you need to know rather, is that you have to identify whether it's similar or not. All right. So you check whether side, the sides are, similar, or the angles, or the side angle side. Okay.